Tonight, like every night, you will do something that looks like doing nothing at all. You will lie down, close your eyes, and vanish from the world for hours. From the outside, you go still and quiet, almost switched off. But inside your body, the night shift is only just clocking in. While you lie there, unaware, a hidden crew gets to work, repairing muscle, washing your brain, sorting your memories, rebalancing your blood. Sleep is not your body powering down. It is your body running a secret program it simply cannot run while you are awake. So what is actually happening in there, in the dark, while you dream? Tonight we follow your body through a single night of sleep, hour by hour. And what it does while you are gone is far stranger than rest. It begins before you even feel tired. All day, while your brain burns fuel, a chemical called adenosine quietly builds up in your blood. Think of it as sleep pressure, rising hour by hour like water, slowly filling a tank. The longer you stay awake, the higher it climbs, and the heavier your eyelids feel. This is also why coffee works. Caffeine blocks the tiny docks where adenosine normally lands, so for a while your brain cannot feel how tired it really is. As night falls, a second signal joins in. Deep in your brain, a small gland reads the fading light and releases melatonin, the hormone of darkness. Melatonin does not knock you out. It simply tells your body that night has come and that it is time to begin. Your core temperature starts to drop by about 1 degree, cooling you from the inside. This cooling is itself a signal, a quiet cue that helps usher you down into sleep. Your heart slows, your breathing softens and steadies. All of this is conducted by a master clock buried deep in your brain, a tiny cluster of cells that keeps time for the entire body. It reads the light coming through your eyes and decides day after day when this whole sequence should begin. Then comes the strangest moment of all, the gate. As you drift off, a cluster of cells acts like a switch, flipping your brain from wakefulness into sleep. Sometimes that switch half fires, and you feel a sudden falling jerk that wakes you with a start. For the first few minutes, you are only in light sleep. You could still be woken easily, and you might even insist you were never asleep at all. But your brain waves are already slowing, stretching out into long, lazy rhythms. The busy chatter of the waking mind is fading, and just below this first shallow step waits a far deeper one, a place where your body does its heaviest repair work. Sleep is not one single state. It is a journey through several, repeated again and again. Scientists divide your night into stages, and you climb up and down them like a staircase in the dark. The first stages are light sleep. Your muscles relax, your awareness fades, and short bursts of brain activity called sleep spindles flicker through. These spindles are thought to help protect your sleep, muffling the outside world so a passing car does not wake you. From there you sink into deep sleep, the heaviest and most restorative stage of all. Your brain waves grow huge and slow, rolling like long ocean swells. This is the hardest stage to be woken from. Pull someone out of it, and they come up groggy and confused, unsure of where they even are. Then, after deep sleep, your brain does something surprising. It climbs back up and tips into a completely different state, dreaming sleep, where the mind comes alive again. Together, This whole round trip takes about 90 minutes, and then it simply repeats. Across a full night, you ride this cycle 4 to 6 times, but the cycles are not identical. Early in the night, you spend more time in deep physical repair sleep. Later, toward morning, you spend more and more time dreaming. So the front half of your night mostly rebuilds the body. The back half tends to the mind. Miss either half by sleeping too little, and you lose a different kind of repair entirely. To see why deep sleep matters so much, we have to look at what your body quietly builds while you lie still. During the deepest stage of sleep, your body switches into full maintenance mode. This is when it does its heavy, physical repair, the work it simply cannot spare the energy for while you are awake and moving around. The signal is a hormone. In deep sleep, a gland in your brain releases a strong pulse of growth hormone, the body's main repair chemical. It travels through your blood like a work order, telling tissues all over the body to rebuild. Tiny tears in your muscles from the day are stitched back together, often a little stronger than before. This is exactly why athletes guard their sleep as fiercely as their training. The gym breaks the muscle down. Sleep is when it actually grows back. The same quiet repair runs through the rest of you. Your skin rebuilds its collagen, which is why a run of bad nights can show up plainly on your face. Cells across your body ramp up the slow work of making fresh proteins, the raw material of repair. And because this heavy maintenance is crowded into deep sleep, your body front-loads it, taking the most deep sleep in the first hours of the night. Meanwhile, your immune system seizes the quiet hours too. It produces and releases protective proteins that hunt down infection, which is part of why a bad night can leave you far more likely to catch a cold. Your body even rebalances its hunger signals overnight, retuning the hormones that tell you when you are full. Skip sleep, and those signals drift, leaving you hungrier the next day for no real reason at all. All of this runs on a schedule your waking self never sees. Bones, skin, muscle, blood, patched and restocked in the dark. But while your body is busy repairing itself, something just as important is happening one floor up. Inside your skull, your brain has quietly begun to clean house. Your brain has a problem. It is the most active organ in your whole body, and like any busy machine, it produces waste. All day, as your neurons fire, they leave behind a litter of used up byproducts and broken proteins. During the day, there is never a good time to take out the trash. The brain is simply too busy thinking, so it waits for night. In 2013, scientists discovered something remarkable about the sleeping brain. As you fall into deep sleep, the cells of your brain appear to shrink slightly, opening up wider channels in the spaces between them. Then, fluid begins to flush through those channels, washing the tissue like a tide rolling through a flooded street. Researchers named it the glymphatic system, the brain's own built-in cleaning network, and it runs mostly while you sleep. What it carries away matters enormously. Among the waste it clears out is a sticky protein called beta amyloid, the very same protein that clumps together in the brains of people with Alzheimer's disease. In other words, a single night of good sleep may be one of the ways your brain protects itself for the long run. This may also be part of why even one sleepless night leaves your head feeling foggy and slow. The trash simply has not been collected yet. The rest of your body has long had a drainage system for this kind of cleanup, called the lymphatic system. For years, the brain seemed strangely left out, with no such network of its own. The glymphatic system may be its hidden answer, a cleaning crew that only opens its widest channels once you are deeply asleep. So, sleep does not just rest the brain, it rinses it clean. And once the cleaning is done, the brain turns to a very different nighttime job, quietly deciding what you will remember. Every single day, your brain takes in a flood of experience, faces, facts, conversations, new skills, but almost none of it is stored properly at first. Fresh memories begin in a small, curved structure called the hippocampus, which works like a temporary notepad, fast to write on, but easily overwritten. If those memories stayed there, most of them would soon be lost. Sleep is when they get filed away for good. During the night, especially in deep sleep, your brain appears to replay the day. The hippocampus fires off the patterns it recorded, sending them up to the cortex, the brain's vast long-term library. Scientists can actually watch this happen, sharp little bursts of activity, as if the brain is whispering the day back to itself, copying it from the notepad into permanent storage. This is why sleep is so deeply tied to learning. Study something, then sleep, and you remember it far better than if you had stayed awake the same hours. It is also exactly why pulling an all-nighter before a test so often backfires. You may cram the facts in, but without sleep your brain never files them properly, and they slip away by morning. Dreaming sleeps seems to handle a different kind of memory, emotional moments, and learned movements, smoothing the rough feelings of the day. This is why physical skills improve overnight too. Practice the piano or a sport, then sleep, and people often perform measurably better the next morning, without a single extra minute of practice. The brain rehearsed the movement for them in the dark. So as you lie there, your brain is busy sorting, copying, and deciding, keeping what truly matters, and letting the rest quietly fade. And nowhere is the sleeping brain stranger than in the stage where those dreams take over. Several times a night, your brain does something almost paradoxical. It wakes up while your body stays fast asleep. This is REM sleep, named for the rapid eye movements that flicker beneath your closed lids. In this stage, your brain lights up almost as brightly as when you are fully awake. And it is here that your most vivid dreams unfold. But there is a clever safety feature built in. While you dream, your brain sends out a signal that paralyzes most of your body. Your arms, your legs, nearly every muscle goes limp and still. This is entirely on purpose. It stops you from physically acting out your dreams, from running, swinging, or leaping while you lie in your bed. On the rare occasions this switch fails, people thrash or sleepwalk, which shows just how important the lock normally is. So why do we dream at all? Scientists still genuinely debate it, and that honesty matters. But one leading idea is that dreaming helps the brain process emotion. During REM, the brain seems to replay the day's events with its stress chemicals turned down low. It is as if the mind revisits hard moments in a calmer space, filing the memory while softening its sting. This may be why a problem so often feels smaller after a good night's sleep. You did not just rest, you quietly worked through it. And as morning nears, your dreams grow longer and richer, right up until your body begins to prepare to surface again. Long before your alarm ever rings, your body is already getting ready to wake. In the final hours of sleep, an internal clock deep in your brain begins to switch the systems back on, one by one. It starts with a hormone. In the early morning, your body releases a rising pulse of cortisol, not as a stress alarm, but as a gentle, natural push toward alertness. Your core temperature, which dropped overnight, begins to climb back up. Your heart rate quickens. Your blood pressure rises to meet the coming day. This is your circadian rhythm, the roughly 24-hour clock that every cell in your body quietly runs on, set by light and darkness. It is why, on a steady schedule, you often wake just before the alarm. Your body saw the morning coming. But the switch from sleep to full waking is not instant. For the first several minutes, you may feel groggy and thick-headed, a state called sleep inertia. Parts of your brain, especially the regions for sharp decision-making, are still booting up. It can take 20 or 30 minutes to truly come fully online. This is also why waking from deep sleep feels so much worse than waking from light sleep. You are being hauled up from the very bottom of the staircase. There is also a reason you feel genuinely restored. All that adenosine, the sleep pressure that built up across the previous day, has been cleared away while you slept. The tank is empty again, and the moment morning light hits your eyes, it strikes that master clock and resets it for the day, locking your rhythm back onto the sun. So by the time you finally open your eyes, your body has already spent hours preparing for it. The night shift is clocking out, and the version of you that wakes is, in a very real sense, freshly rebuilt. So what happens inside your body when you sleep? Almost everything that keeps you alive and keeps you yourself. Your muscles are repaired, your brain is washed clean, your memories are filed, your emotions are settled, and your whole body is retuned for another day. Sleep is not lost time. It is the maintenance window that makes all your waking hours possible. So tonight, when you lie down and vanish, remember this. You are not switching off. You are handing the controls to a crew that only works in the dark. And if your body has its own secret night shift, then what about the strangest signal it sends in broad daylight? That helpless, contagious urge we still barely understand. Why, exactly, do you yawn? That is a mystery for another video. This was Doodle Anatomy.